Hi everyone, thank you so much for tuning in. We are starting our new unit today on rational expressions, and this is unit 7, and we are going to be talking about day 1 of that unit, which is going to be simplifying rational expressions. And by definition, a rational expression is basically a polynomial that is in the denominator of a fraction. So they could also occur in the numerator, but the important thing is that the polynomial is now also in the denominator, or in other words, we have at least one variable in the denominator of a fraction. The way we simplify them is the same way we did simplifying of fractions or reducing of fractions in elementary school, where we divide both the top and the bottom of the fraction by the greatest common factor. You can see that we took the fraction 2/10 and reduced it to 1/5. We're going to be doing the same thing, although obviously it's going to be a little bit more complicated. If we are given this rational expression, 2x to the 5th minus 8x to the 3rd over 6x to the 9th, and we have to simplify it, we need to find a GCF, or common factor, to both the numerator and the denominator that we can divide out. So what I do is I factor out the GCF from my numerator, and I compare it to my denominator, and I see that they do have commonalities. I can reduce my 2 and my 6, and my x to the 3rd, and my x to the 9th. And when I do that, I'm left with just 1 at the top and 3x to the 6th at the bottom. So now I can rewrite my answer as x to the 3rd minus 4 over 3x to the 6th. One of the most common mistakes that people make when they simplify fractions is they cross out, for example, like this, the x's. So this is different than what we did up here because of this addition in between them. So it's more easily able to be seen why we can't do it in a problem where we have numbers. If we had 5 plus 1 over 5 plus 2, that would not reduce to 1/2. That would become 6 over 7. And the reason for that is because the fraction bar, the vinculum, acts as a grouping symbol. So it's making us do the addition in the numerator and denominator before we can simplify that fraction. So in doing so, this is not 5 plus 1, it's 6, and this is not 5 plus 2, it's 7, and therefore we cannot reduce those 5's. Similarly, we can't do that here. We cannot reduce the x's. So the big rule that we have to keep in mind that everyone forgets is that you cannot cancel out single terms of polynomials. You can only cancel out factors, things that are being multiplied together. I cannot stress how important that is and how common a mistake it is. So make sure that you get that down. Okay, the last thing we're going to talk about today are operations with rational expressions, starting with addition and subtraction. So remember, adding and subtracting fractions, it kind of stinks because we need to have that common denominator. And just as a visual reminder, this is why. When we try to add two different fractions with different denominators, it's like adding two different types of pieces of a number. And we can't do that. So the very first thing we always have to do is to make sure that the denominators are the same. So if I think of my 1/3 as being 2/6 instead, now I can combine them and say, how many sixths do I have? So when we add fractions, we only add the numerators. We had to get our denominators the same, and we keep it the same, and then we simplify at the end if we need to. So 3/6 is the same thing as 1/2. Same rules apply when we add rational functions. We need a common denominator. So if we take a look at this problem here, we're subtracting, but the same rules apply. It's the first thing we want to do actually is within this fraction, if there are any numbers that can be reduced, we certainly want to do that because it makes our problem simpler and it makes our common denominator simpler. And if we compare our denominators, we can see that the r is common to both, but the 2 and the r minus 6 are only in the second fraction. So to make this a common denominator, we need to multiply this fraction also by the 2 and the r minus 6. So that gives me a common denominator of 2r, r minus 6, and I had to multiply my numerator by the 2 and the r minus 6, because I had to do the same thing to the top and the bottom. So the bottom became this 2r, r minus 6, and the top I had to multiply by all of those missing factors, basically. The second fraction contained all of the common factors, so that didn't need to be changed at all. And then all we do is multiply and then subtract our numerators, keeping the denominator the same. So when we distribute this 2, we end up with 2r minus 12. And when we distribute the negative, it becomes minus r plus 3. Again, the denominator stays the same. We combine like terms and we end with r minus 9 over 2r, r minus 6. As we move into multiplying and dividing, remember this is much, much easier with fractions, so this should go faster. When we multiply and divide, we want to simplify the fractions if needed. Now what's interesting is, remember how we talked about you can only simplify factors, not individual pieces of polynomials? But now we can cancel out the top of the fraction with the bottom of any other fraction that we're multiplying, because those are all kind of being multiplied together. They're all factors of each other. So that's kind of exciting because it gives us a little bit more flexibility. So we can now cancel out the 3 and the 9, or reduce the 3 and the 9 and make it 1 and 3. And then we just multiply our numerators and multiply our denominators. And so we get 3 over 16. Okay. Same thing here. We can reduce or cancel out first. In order to do that, we need to factor any polynomials to see if they match any factors at the bottom. So again, we can't cancel out individual x's or individual negative 8's, but if they're grouped together as a factor, we can. So those will reduce together to 1 and 1, and then we multiply our numerators and multiply our denominators, and we're left with x plus 7 over 7x. Dividing is almost as easy, except we have the added step, remember, of having to multiply by the reciprocal. So dividing by a fraction is the same thing as multiplying by that reciprocal. We can simplify the fraction next, just like we did. So we just follow the multiplication steps, and then we just multiply our numerators and multiply our denominators. Same thing here. We multiply by the reciprocal. If we can simplify, we certainly want to do that. So I need to factor any polynomials. Whoops, those don't. A minus 4 and a minus 4 are common factors to the top and bottom that can be reduced. And then it's just multiplying the numerators and multiplying the denominators. Okay. The last thing I want to mention is to remind you what a complex fraction is. It's a fraction that is contains another fraction either in the numerator, the denominator, or in both. A fraction is just another way of expressing division. So we could also write this as 2/5 divided by 10, which would, dividing by a fraction also means multiplying by the reciprocal, so it would also be 2/5 times 1 over 10. So if you see a complex fraction, it's really just a division problem, and you would follow the same steps here. Okay, so that's it. Thank you so much for watching. If you have watched until this point, please do me a favor and write down any questions that you have from the video or anything that you learned from the video, and send me a quick email with it. Thank you so much. See you guys in class.